Namaste GATE aspirants, welcome to the GATE Tuber YouTube channel. In this video, we'll extend the lecture of engineering mechanics from the previous lecture. Today, we'll see the first topic, triangle law and sine rule. What is the triangle law? It is similar to the parallelogram law we have seen earlier to find the resultant of two forces. But in the triangle law, it explains the finding resultant in a different way. When two coplanar forces are acting as the two sides of the triangle, then the resultant is the one which is closing the triangle in the opposite direction. That means initially there are two forces which are acting as the two sides of the triangle in the same direction. I'll draw the figure. Let's understand from it. A is the first force, which is the one of the sides of the triangle, and B is the continuation. A and B are the two forces which are acting as the sides of the triangle and they are in the same direction. But the C is the force which is acting in the opposite direction and is closing the triangle. Hence, C is the resultant here. I hope you have understood. Now, let us see the sine rule. See, this also can be proved from the triangle law only. So PQR is the triangle. Same, Q and P are acting in the same direction and R is the resultant which is closing the triangle in the opposite direction. So if you extend the sides up to their perpendiculars, you can see that sum of the angles in the triangle is alpha plus beta plus gamma is equal to 180 degrees. So as I named ABC and RPQ are the forces. So angles AC is a straight line, so 180 should be the angle on it. If you see there, gamma is the angle between the P and Q. Therefore, the other side should be pi minus gamma on the right side and the below part also. Therefore, BC is equal to P sine pi minus gamma, since it is the projection, that is equal to R sine alpha also. If you observe the diagram, R sine alpha is the vertical projection which is equal to BC, and P sine gamma, since 180 minus gamma is sine of 180 minus some angle is sine of 180 minus theta is equal to sine theta from the trigonometry. So BC is equal to P sine gamma is equal to R sine alpha. So from this P sine gamma is equal to R sine alpha. From this P by sine alpha is equal to R by sine gamma. Similarly, if you take OD is equal to R sine beta. From the figure, you can see that R's vertical projection is equal to OD and Q sine pi minus gamma is equal to Q sine gamma, that is also equal to OD. So we can conclude that R by sine gamma is equal to Q by sine beta is equal to P by sine alpha from these two relations. We can conclude the sine rule as ratio of the vector or ratio of a side of a triangle to the sine of angle between the other two sides is constant. So this law can be applied anywhere. Hence this law, parallelogram law, and the upcoming theorem, Lami's theorem, are very useful in engineering mechanics, particularly in statics part, very much. And Lami's theorem. What is Lami's theorem? If there are three forces A, B, C which are in equilibrium, then the forces can be written as ratio of the force to the ratio of the angle between the ratio of the sine of the angle between the other two forces. It is similar to the sine rule. Hence, from the figure, A by sine alpha is equal to B by sine gamma is equal to C by sine beta. I think I have drawn correctly and represented correctly. So this also can be proved using the triangular theorem. I have left a hint below. So drawing the diagram of the triangle. So this can be proved similar to the triangle law. So we need to remember how to apply this Lami's theorem and triangle law, sine rules and parallelogram law whenever we required in the problems. So you need to remember the concepts there. Next thing is Varignon's theorem. What has Saint Varignon told or proposed? Algebraic sum of moments due to all the forces in the system is equal to the moment due to the resultant about the same point. So I'll explain the theorem using a diagram. Let us consider there is a body or a system which contains the forces A, B and C. So the moment produced by the three forces at O is equal to A. Let us call the forces simply with the A, B, C names. A into distance between A and O, shortest distance. So let us assume that AO is known. So A into AO plus B into BO plus C into CO is the moment produced by the forces individually. What Varignon said? The moment produced by these forces is equal to the moment produced by the whole resultant of these forces. So if there is a resultant of this A, B, C, which is known as R, then MO is equal to A into AO plus B into BO plus C into CO is equal to R into the distance between O and R, which should be the shortest one. So R into RO is equal to sum of the moments of this forces about the same point. This is what Saint Varignon said. This is also used in the problems very frequently to find the resultant of the forces. So you need to remember the theorem also. So simply I am showing it with an example. If A is 5 and the AO is 3, B is 4 and BO is 2, C is 6 and CO is 2, the resultant will be 15 plus 8 plus 12, that is 35. So according to the Varignon's theorem, 35 is equal to resultant force into distance between the resultant force and the point O. If the distance is known as 5, then the resultant will be 7 newtons. The problems will be similar to this example. Therefore, now we have completed all the theoretical concepts in the equilibrium of forces and free body diagrams chapter. Now we'll go to the problems from the next lecture. So if you have any doubts, please comment in the comment section, share the videos to the needy and subscribe for updates. Thank you.